IEEE Victoria presentation. This is a joint event from Antennas and Propagation, Microwave Theory and Techniques, and also the EMC chapters. My name is Les Davey from AP and MTT. I'll be hosting today. Also online we have our chairperson, Fatima. The title of today's presentation is Navigating EMC Compliance from Design to Manufacturing. And judging by the large number of registrations, this is a topic of much interest. We have quite a few registrations from both interstate and from overseas. So a special welcome to those people who are joining us. Our presenters today are Yasser Darbin from Entech Electronics, Scott Williams from Zentronics, and Aaron Gain from EMC Technologies. To save time, I won't read through their biographic details. They'll make a brief introduction themselves, but suffice to say that collectively, they have many years of experience in EMC covering design, manufacturing and compliance. The format for today's presentation is 50 minutes for the presentations, followed by 10 minutes of questions and answer at the end. So we'd ask you to hold off your questions until then, and you can see on your screen that you can actually write in your questions during the presentation. So Yasser is going to start off, followed by Scott, and then Aaron. So I'll hand over to you, Yasser, to commence.
Thanks, Les. I appreciate the opportunity to have a presentation for the audience today. I would appreciate Scott and Aaron and your team at IEEE to joining the session. Without wasting any time, I would just go into the topic, navigating EMC compliance from design to manufacturing. EMC, we would say that it's more about designing and getting certified. Manufacturers don't have so much influence, but I'll explain that how it works. As for Entech, we are electronics and complete products manufacturer, so we are taking care of the supply chain issues and trying to reduce the risk and time and cost for any projects, any products from design stage to the commercial stage. We are not designing anything anymore. We are using good partners like Scott and other teams in Australia and New Zealand to provide the design, but we are specialized in manufacturing. So what I'm going to touch is more about manufacturing aspects of this topic. Just a very brief introduction of Entech. We are a team of over 100 people, around 130 people in Adelaide. We have 250 people over in our offshore facility in China. Our both factory are certified for 13.5 medical device compliance, 9001 quality system, and AS9100D for aerospace and defense project. In Adelaide, we are certified, 100% Australian owned, and our focus is a lot of production, different area, but I would say IoT devices, medical devices, aerospace, intrinsically safe products are among those that we are focusing. We don't do design, but we are providing lots of design for manufacturing review and design for test review. We have a good engineering team that they can help designer and end user to reduce the cost of products and production that they are planning. So going to the topic, responsibility of manufacturer related to EMC. Manufacturers are responsible to build, and anything related to EMC compliance and design criteria need to be considered before a data package come to us. So we see time to time clients are asking us, hey guys, I have this product, can you certify this for us? We say, no, this is not our job. You should have considered all the design aspect and get it certified. So when it's finished, we are ready to manufacture. But it doesn't mean that we are not responsible. We can have a reasonable influence to certain aspects of design. Whether it's electronic design, we can give some recommendation and advice, or whether it's the complete enclosure, post-assembly or final assembly. We can give share some experience. I mean, when I say we, I'm talking about any typical OEM contract manufacturer. The contract manufacturer, they have certain exposure in terms of assembly and production and manufacturing, which they can share that with the design house, they can share that with the customer. You don't want to do an excellent design. One thing that customer or client need to consider is that their criteria in terms of manufacturing, quality of assembly and manufacturing, customer definitely don't want to design something and then anything goes wrong in like assembly or production by making any mistake. So you need to make sure that the manufacturer is able to deliver and build according to your design. And I'll touch on this a little bit in coming slide. So exactly what can go wrong in manufacturing? Basically, the sort of suggestion and advice we can provide is that you finish a design, you get your design certified, and then there's some part which is going end of life. And this is happening every day, you know, especially with the current market is very unstable. You need to know if the part that you are designing and if that part which you're going to get it certified by the good expert like Aaron and his team, like EMC Technology, is that product end of life. Of course, some good designer, again, like Scott, his expert, they can give some suggestion. They have visibility on end of life to some extent. We are providing feedback to some of the design houses, what is happening in the component market. But as a product owner, you need to consider this. This can go wrong. And if it goes wrong, means you need to design another part. You need to get that certified again. It will waste time. It will just delay your product launch to the market. And if the manufacturer secure parts from unknown or unauthorized distributor, especially with the current market situation, we are hearing people going to the gray market more and more, which that can put your whole product at risk. I believe Aaron going to explain some of the penalties later on for touching some risky part and the consequences that you may face. So you want to anticipate any change or any component shortage or any component lead time or any production limitation, whether it's the potting material or whether it's the plastic material, manufacturing time. You need to consider everything before you go to production, and that is something that a manufacturer can help and avoid and not let it go wrong, I would say. Material selection and sorting, which I just mentioned, recertification, end of life, and dealing with authorized distributor are the top issue. These are mainly around the electronic parts, but we see situation and we see change or information around other, like whether it's the enclosure or whether it's the plastic. We are using a certain potting material which is certified, but something will change. And the whole EMC compliance, it's not just about the electronics. If you're dealing with the contract manufacturer, which they're expert in PCBA, just the electronic assembly, that is great. But EMC is around the whole product assembly. You will get the whole product certified. So you need to talk with the consultant who have this experience of putting everything together. Just few consideration. I'm trying to give more time to Aaron and Scott because they are the core part of this presentation today. The consideration is that do not overcomplicate your design. Just talk to your marketing and sales team. These are the cases that we see. People, they come and they design something and they certify it for Europe, for US, for Japan, for UK, for Australia. And at the end, they just need to sell it to US for the first 1 year. Why you are just certifying yourself for everything? It will cost. And you can do some of this in version 2. So understand that what is your exact requirement and talk to expert. But don't miss anything. If you miss one of these certification and you go to market and suddenly after 3 or 6 months you realize that you need to go to another market that might be another sort of certification or compliance requirement, you need to consider that few months ahead and be ready. So don't disrupt your production. That costs companies huge money. These disruptions are something that no one can do it. There is no magical that you pay extra, you get it done quickly. There is no way. There is a cycle. You can't bypass the cycle. Use the right consultant. Of course, lots of good designer we have, but we have designers that they're focusing on EMC. They're expert like EMC technology, that this is their life, and they can provide good consultation at a very reasonable cost, very early during your design and development stage. They can complement your design strategy or design team. What we see is that the companies that they're using good consultant are making more chance of success along the line. Talk to contract manufacturer before freezing your design. Let us have a look. We are not going to design anything, but we can just provide some high-level suggestion and advice based on our experience, whether it's around like shielding or the gasket or enclosure or the whatever it is. We can just give some high-level suggestion to yourself or to the designer, and that helps you along the line. As I mentioned, it's not just the PCBA. Check everything as of the full product assembly, and be ready before you go to the production. Perhaps you don't want to go to production and then suddenly you realize you missed something that will cost you a lot of time and money to recover. I'll pass the screen to Scott.
Thanks, Yasser. Just give me a minute. I'll share my screen here. Yeah, so can you see that fine? Is that okay?
Yeah, that's all good.
Perfect. Thanks, guys. All right, so it's a pleasure to be talking to you all today. I'm really excited to share this presentation and talk about something I'm quite passionate about. So let's get stuck into it. So today I'm just going to talk about some product design considerations for EMC. So just a brief introduction on me. So I'm an electronics design engineer by trade. I service all industries involved in product development, whether it be as a designer, so doing schematic PCB designs for people, or as a consultant, so doing design reviews, EMC testing, manufacturing support, and even training. So if you want to find out more about me, my website's there. Go ahead and take a look. Otherwise, let's get stuck into it. So for those in the audience who aren't even sure what this EMC thing is, is it what exactly are we talking about here? So at a high level, right, it's ensuring two things. So the first is that your product as a whole, so not just the electronics, as a whole, your product doesn't interfere with the environment around it, okay? That could be other products, that could be equipment, that could be people, okay? On the other hand, it also ensures that your product can sustain interference from the environment around it. Again, that could be a product sitting next to it. That could be equipment in a factory. That could be a person touching it, hitting it with static electricity. That's all EMC is, sorry. So quite simple. It makes sense when you think about it, especially like nowadays we've got rooms filled, you can see behind me, rooms filled with technology and a living room which has sometimes thousands of PCBs for your sound entertainment system and your television and all of that sort of stuff, right? It makes sense. And at a low level, I'm not going to go into the details too much, but all it is it's full phenomenon. There's nothing else, nothing more. You can have magnetic fields from parts of systems coupling into others, inducing currents. You can have electric fields from systems coupling to others and inducing voltages. You can have two products. These could be two products, or these could be two PCBs in your product. Doesn't matter. The concepts are the same. If they both share the same power source, noise from one can couple to the other through their common impedance along that power line. This could be mains. This could be a battery. Doesn't matter. And then the last, of course, is when you've got electrically long cables in your system, those cables can act as actual antennas and actually radiate into the far field. So these four concepts you see here, that's all it is. There's nothing more, nothing less. It's not just noise coming from nowhere. It's real physics 101 phenomenon that are happening, okay? It's important to touch on that compliance isn't EMC, okay? there's much more to product compliance. So there's safety testing, whether that's isolation, creepage, earthing, fusing, radio testing. If you've got Wi-Fi or Bluetooth in your device, EMC and the radio testing, they're actually separate things. They're not the same. Environmental testing, and even more. So if it's a medical product, there's specific medical testing for leakage current. If it's an automotive product, there's specific immunity transients you need to be resistant to, all of those sort of things. Here's some overview there you can see. They have all their own design considerations. I'm not going to touch on them today, unfortunately. It's too much, but please keep that in mind. EMC Technologies offer these all as a service for your testing, which is really great. It means you can send your product to one test house, all the tests are done, and you get the big tick. It's really, really nice. And that's one big reason why I partner with them for all my projects. Now, why should you care? So look, all products must be compliant, not just specific industries and not just products that are sold. I have a lot of clients in the past who they either have an IoT product that they just rent out to their customer, or even a product that they might use in their own factory, but they don't sell it to other factories. It's just their own product. And they think they don't have to certify because of that. And that's just not true. So if it's in the environment and it's being used as a final product in a system, it's not a prototype, it's not a part of a development, it needs to be certified. So, and compliance has design implications that are often neglected, right? Poor decisions throughout your development process can end up increasing the development costs with redesigns, compliance costs. So if you've designed your product to be overly complicated, it needs to be tested in 5 different configurations. It has 6 different modes of operation. It's just going to take longer to test it. It's going to take longer to certify it. Production costs, so late additions to the assembly, so an extra filter on the output, extra shielding with alfoil inside, right? Whatever it might be, you're going to be adding to those costs down the track. And obviously time to market, that's a big one. A non-compliant product in the wild, this is heavy, but it can result in damage, injury, or death. So that's the truth. That's the reality of it, and that's a big part of why I'm passionate about it. Let's have a little look at these clips. So this is a basic overview of EMC in the real world. It's very simple examples. So you see this guy, he's just sitting in a chair. He goes to stand up. As he stands up, both his monitors just reset. So they didn't just go sleep mode, they actually reset. Now that's, a monitor resetting isn't the most harmful thing in the world, but it still shows the concept nonetheless. You'll see all that's happened here is, this is an example of ESD. As he's sitting down here, due to the triboelectric effect, his skin is giving off, compared to the wool jumper he's wearing, it's giving off a lot of negative charge onto the wool jumper as his skin's becoming more positively charged underneath. It's also adding to the chair he's sitting in. And these, even though you can't see it, doesn't mean it's not there. This is causing a huge, actually that's the other way around. This is causing a huge electric field from the environment around him, coupling to him. And then as he stands up, it's just an oversaturation of that. And it's enough to induce some field issue in here, capacitively coupled to his body, that causes a reset. And this is something that should get picked up in compliance testing. Here's another example. This is in my office. This is only a week ago. I actually got these fluoro lights installed. And you see the fluoro lights above my monitor reset my monitor. So same thing again, it's electric field again. It's not ESD, but nonetheless, that's an issue with my monitor. That monitor is not, it may be compliant to the standard, but you see here, nonetheless, it's an annoyance for me. These are pretty, light touch examples, but nonetheless, they show that could be you sitting at a traffic light, you turn on your headlights, you're next to the control system for the traffic lights, and it resets the traffic lights, and there's a crash in front of you. It's the same concepts, okay? So let's break it down. So my system for design, troubleshooting, whatever it might be, it's a 3-tiered analysis. So there's the product level, the system level, and the PCB level. People think EMC, they just think the PCB. That's not the case. I'll go into that. So you see here, here's an example. It's just the easiest product I had on hand. It's my oscilloscope. You can see that's the product level. We've got where are the buttons, where's the display, what's the case made out of. The system level, so where are the connectors, how are the boards all connected, do we have heat sinks, do we have shields, and then the PCB level, so down to the copper traces, where are components positioned, how are they connected. Each tier of these has their own considerations, measures, and pitfalls. So it's quite a lot, right? There's a lot going on here. That's why I like to break it down like this. And as I said, this is development, review, troubleshooting, whatever it is. So let's look at the product level first. So this rarely gets input from an EMC and compliance standpoint. Even me, I don't think I've ever really contributed to this for any project, because clients come to me with their design and they already know what they want. They know they want a display here. They know they want buttons here. Okay. but these can all have consequences down to where your connectors go. Is the USB power this side or is the USB power this side? That all matters, okay? So some examples as well, things like regions of certification. So yes, I touched on this. Again, every customer I think I've ever had is, I ask them, where do you want to get this certified? Where do you want to sell it? And they say, oh, globally, right? We've got to sell it globally. Are you really going to be doing that though? Are you going to have a distribution chain? Or are you going to be shipping them for $200 freight for each unit, right? It's thinking about where you're actually going to sell them, because the more regions you certify, the more costs you're going to occur, and the more complex your design is going to have to be, because different regions will have different tests. Okay, the enclosure material, finish and design. This one's pretty self-explanatory. Any EMC engineer would love every product to be in a metal box, perfectly bonded with 360-degree shielded connectors. Not practical, of course, but there's a balance to strike there. Not everything should be injection molded. Okay, the size of the product. If you're trying to make a product this small to be a police body cam with Wi-Fi, GPS, battery powered for 5 days, and all of these features in this small space, it's a lot more challenging to pass compliance than a product this big, right? And the intended environment of use. So most people don't realize that if a product is designed to be used in a residential environment, okay, versus a industrial environment, it needs to conform to 10 times more stringent standards for its emissions. So what comes out of the product. On the contrary, though, you can't just say it's industrial, because on the industrial side, you need to be resistant to 10 times more immunity from other sources, right? So there is a balance to meet there. Sorry. So system level, moving on. So some sources and victims. When I say sources and victims, I mean, before in that video, the source was the person standing from their chair. The victim was the monitor, okay? Some of them can't be fixed at the PCB level, okay? This requires management at the system level, okay? So things like the power source and inputs, the board-to-board interfaces, cables and shielding, that's a big one. The shielding industry is a whole market in itself, but oftentimes it's not necessary. Obviously grounding, earthing, return currents of your product. As a whole in this system, where are the currents flowing, both the high frequency, the medium frequency, and the low frequency? And obviously heat sinks, board level shields, and large components, right? Heat sinks is a big one. A lot of products these days might have like a Raspberry Pi slapped inside. Those almost always need a heat sink if they're used as a real processor doing heavy lifting. And you've got a processor like that sitting on a PCB, and you've got a heat sink that you've just slapped on top. So for those who don't know, heat sink's just sort of like a block of metal, I guess, with some fins along it. When you've got that just slapped on top with, say, some adhesive glue, all the electric fields from the gigahertz and hundreds of megahertz clocks from the processor just couple to that, because it's a floating piece of metal. And that essentially acts as I guess you could say, an amplifier. It's not an amplifier, but as a larger capacitive source for electric field coupling to nearby circuits, to cables which are coming off the board. Okay, so heat sinks are a big area where it's often not even thought that this is an issue, and it's something that is. Again, no matter how well the PCB is designed, these elements can still cause issues, right? And then last, of course, is the PCB level, right? That's the heart of all EMI. It's all going to come from the PCB. There's no doubt about that. There's a lot of application notes, a lot of rules of thumb about this, your 100 nanofarad caps and all of that. Most of it, is sort of probably incorrect for modern technology, right? Modern processors, modern frequencies, modern rise times. Here are some things that are generally done. Most designers I've met, if not all, do this. They understand EMC is an issue. They understand, all right, we need to have decoupling capacitors. We need to have a power filter. We need to have, DC-DC converters. They're very noisy. So we need to be careful where we put them. That's great. It doesn't go far enough usually though. So this is where where it goes wrong. So you can have decoupling capacitors, but down to the 0.1 millimeter of where you put the vias, where you put the chips, or your stack up, that can either make the capacitors useless or very useful. Filters, you can design the filter in the schematic, but physically on the board, there's going to be parasitic capacitance and things like that, which can cause noise to just bypass the filter. All right. And even like controlled impedance. Most people know, okay, USB, let's put USB on the circuit board. It needs to have 50 ohm controlled impedance. That's great. Most people do that. They get the stack up right, or they tell the manufacturer. But most people don't realize USB, it's pseudo differential. Okay, so what that means is it will have a data plus and a data minus line, right? That's the data's traveling along that. But because it's pseudo differential, there's going to be a point where the two data lines don't perfectly cross over here, right? And that's going to cause a little common mode spike like that in the same direction on that data line. And so that needs filtering, that needs managing, and people don't even realize that. No matter how controlled your impedance is, common mode current flowing on a cable isn't going to fix it. There's a lot to it. Won't go into the details here, but just touching on it there, that the PCB does matter, but so do all those other levels. So just to make things interesting, I thought I'd give a little example here. So let's talk about connector placement now. This is getting quite detailed for those who aren't a designer, but I'll try and walk you through it as much as possible. So this is a PCB looked at from the side. Here's just from the top angle, just so you have a bit more of an idea, okay? And for some reason, whatever it is, it's specified by the industrial design or it's specified by the electronics guy, whatever it is. We've got two connectors on two sides of the boards. These go off to a cable, okay? On this side as well, these go off to a cable, same as over here. This is the same connector here and here, okay? Now this is a very basic stack up, but it's just for the simplicity and for demonstrating the point. Just a 2-layer board. Here we have our ground plane. For those who don't know, the ground plane is just, that's the 0 volt reference. So that should be the same voltage set at the 0 volts. All systems you can see here, all of them, the connectors, the two chips that are on the circuit board and the other connector, they all reference that. And that's where all the return current flows, okay? Now, here we've got, you can sort of see, there's a trace here connecting these two chips, and these can just be any two chips that are talking to one another, and they're sending data on this data line. So it's just, 1 0 1 0 1 0, doesn't matter what it is. It's important to realize when data is being sent on a data line, it's not just voltage. There is actually current flowing on that data line. It's not a lot of current, but it is current flowing. That current obviously has to return back somewhere. Current flows in loops, so that current is actually going to return along that ground plane like that. Now, even though these connectors aren't related to this circuit at all, these are just bonded to the ground plane. In fact, in this example, I'll show all 4 of these connections here. They just tie to the same piece of metal, just a big piece of metal. So there shouldn't really be any voltage difference. There shouldn't be any radiation or anything like that. But what I'm showing here is because this is a high frequency data pulse that's happening, it's not DC current, there's going to be high frequency flux, actually that's the wrong way around, sorry, flux wrapping this board in both degrees, okay? What that means is, because what that effectively means is in a lumped circuit model, that means there's an inductance in that return path, right? Most people know what inductor is who've done engineering, right? From Electrical Eng 101. All this means is there's actually going to be a bit of a voltage shift in that ground plane as that current returns. Now, in the world of EMC, a voltage shift that's toggling on and off, on and off, on and off because of the data, okay, that's the same as if there was a voltage source. It doesn't matter if it's a voltage drop or a voltage source. Doesn't matter. It's the same thing from an EMC engineer's point of view. That bonds to this side of the board, okay, which this area here has the same potential, and this bonds to this side of the board, and again, this side here has the same potential. And if you look carefully with these cables coming off the board, even though these are just bonded to the ground plane, nothing else, you've effectively created a dipole antenna. So this board, which we've got 2 connectors, they have nothing to do with the circuitry. They're bonded to the ground plane. They're going to radiate, despite there not being any, effectively any, I guess you wouldn't say any current flowing on it, but any intended current flowing on it. You can see here the solution's quite simple. You just have to move both connectors to the same side of the board. If you do that, they're both going to be in the same area. There'll still be this phenomenon I'm showing here, but it's not going to cause a difference between cables. And just to demonstrate the point, I went to the effort of actually going to EMC Technologies and testing these designs. And before I show that, just to show you, I'm powering these boards off a battery. So there's not even power coming on these cables. All they are is there's just one chip sending data down here. That data terminates and returns, and nothing else. These cables bond to the ground plane, nothing else. And you can see here quite a clear difference with these spikes, with the CISPA limits being something like this. I can't quote it exactly, but something like that. We've got clear failures here versus this, where we would be in the green quite comfortably for the whole product. So that just shows you that simple design choice there has done that, right? You can see here, this is the ground plane of the board. This is all just the same piece of metal. And probing with my near field probe, picking up all that magnetic field you'll see there's heaps of energy in that, right? So it's important to know things relative to other things actually is really important. You can't do anything about that. There's nothing you can do. That's physics, but you can do something about where you decide to put your connectors. So I'll just show you a brief example here. This is a Chromecast. A lot of people know about this. 2 connectors separated by high speed signals, just like I just showed. Same concept, okay? The ferrite bead you can see here, that's been added on during compliance testing to try and attenuate the emissions. Now I'll do a hypothetical example here. What was the cost of deciding to put these connectors on the opposite side of boards? Let's say, assuming this product failed because of that phenomenon I showed. I can't say for sure, I don't work at Google, but say that was the reason, and they had to add this ferrite bead because of that. Well, let's assume 50 cents per ferrite bead for materials and labor at manufacturing to fit that. 55 million of them were sold as of 2017. I'd say it's safely 100 million by now. That was nearly 4 years ago. So 100 million, 50 cents a ferrite bead fitted. That's $50 million that this has costed Google, potentially, right? I'm being hypothetical here, but let's say that if that was the issue, they could have just had the same connectors on same sides of the boards, or made the product slightly bigger. It's not as slim, not as sexy, but that could have just saved them $50 million. Who knows? I don't know, but let's just be hypothetical here. So, did these really need to be on separate sides? Does the USB cable really need to be that long? That's going to make the emissions worse by having a longer cable. Gives the harmonics more chance to radiate. So I'm nearly at my time here. I'm at 19.5 minutes. So I'll just do a closing word. Compliance shouldn't be seen as an annoyance or a constraint. Designing a compliant product is challenging. There's no doubt about that. But fixing a non-compliant product is way more challenging and costly. Compliance, look, it does these things. It verifies the quality of your product. It's going to reassure your end customer, sends a message to your competitors. It's going to encourage uptake from your suppliers. If you're not selling direct to customer, if you're trying to convince people like JB Hi-Fi, Kmart, whatever it might be to sell your product, compliance is so important for that. And a big one, it protects your employees, and is something you need to consider during design. So that's me wrapped up. If you've got any questions or want to find out more, there's my email there, and I'll hand it over to Arun now.
Thanks, Scott. Thanks, Yasir. Just give me a sec. I'll share my screen. Okay. Yeah, first of all, thanks to all of you for your time and attending this webinar, and thanks to IEEE chapter for organizing this webinar. I will quickly jump into the topic of this compliance. Yasir and Scott has nicely explained why this EMC compliance need to be taken care of from the design point of view as well as from the manufacturing. I will mainly try to focus on from the regulatory point of view why this compliance is necessary. Let me quickly introduce myself and our company, EMC Technologies. My name is Arun Gayan, and I'm the Melbourne branch manager here in EMC Technologies. I've been in this industry, they call it the TIC industry, the testing, inspection, and the certification industry for over 15 years while working in several countries, England, Japan, now in Australia, and taking care of compliance for several products, I would say. Okay. Now, who are we here? The EMC Technologies. Let me. Okay. So EMC Technologies, basically, it's an independent Australian-owned company. We established in 1992. We are one of the largest and the most accredited test house in Australia and New Zealand. Okay, we got NATA and IEEE accreditation for the ISO standard 17025 and 17020. We got facilities here in Melbourne. We got facilities in Sydney and New Zealand, Auckland. What do we do actually? We provide regulatory approval testing and consultation services to all the areas of electrical and electronic industry, okay, including EMC, electrical safety, radio, wireless, whatever you need for the compliance part, and covers many areas from commercial, military, automotive, medical industries. Okay, we are also the ACMA EMC competent body as well as the telecom certification body. We provide local representative service here in Australia and New Zealand, and we are also European notified body for EMC directive. I'll straight jump to the main topic of today. That's the compliance topic. Why a product need to be compliant? It's mainly in terms of the regulations. Okay, Yasir and Scott has explained from the design side. I will basically explain why a designer or a manufacturer or basically a seller need to comply with the regulations here. The first and the foremost thing here is selling a safe product to the consumer. We don't want to sell anything which is unsafe. Okay. The second point is basically meeting regulatory requirements. Okay, I will explain them all one by one. And then the third point is basically preventing from product recall. And the last one is, of course, we don't want any penalties or fines for selling some unsafe product. Let's go through this, what I mean to say here by selling safe products to the consumer. Okay, now there are two topics when we talk about the safety of electrical products in the market. One is the electrically safe, the other one is safe to the electromagnetic or the radio frequency environment. Now, as you can see here in the picture, of course, that's the extreme level. You know, when we talk about this electrically safe product, it can basically, it's the risk of getting someone electrocuted in terms of electrical shock, getting fire, explosion, burn, and even mechanical injuries. So they are covered in the safety part, of course. But when we talk about the electromagnetics, basically we are talking about the interferences which are caused due to those noisy electronics or the microprocessor, I would say. Nowadays, of course, we have a lot of intentional radiators as well, which are basically communicating and interfering with other devices which are susceptible. Now, the second point about meeting the compliance is basically meeting the regulatory requirements. Now, there are different requirements for different countries. Okay. Now, here in Australia and New Zealand, the product need to comply with regulations basically coming out from ACMA and IRAC. They call an RCM marking here. To obtain that RCM marking, the product need to comply with those two regulations coming out from ACMA and the IRAC. I will explain a little bit more about those two. There are other markets like Europe. When we are going to Europe, we need this product to be CE marked. If you're going to USA or Canada, they have to be FCC and Canada. Yasir was pointing a very important thing here, like when we are trying to sell a product to different markets, it's best if we can plan ahead and try to cover as much as market as we can, because all these markets have different requirements. For sake like Australia and USA, they only are looking into the emission aspect of those requirement. But when you go to Europe, they also look for the immunity requirement. So whether your product you're planning to sell in 6 months time in Europe, then you should comply as well as basically test it along with the emission. It reduces a lot of effort from the manufacturing side, from design side, as well as while we are doing a testing. I'll explain a little bit more later on in one of my slides. Now, just to cover this topic about meeting regulatory requirement for Australia, I was explaining about these two major requirements coming out for RCM marking. One is the one who's coming from ACMA. They cover the EMC requirement, the telecom requirement, radio requirement, and the EMR requirement. Plus, the product needs to be electrically safe, and IRAC is basically mandating all those safety requirements. Now, the third point is basically nobody wants a product to be recalled. If you're selling a product in the market, you don't want to see this product being recalled after a few days or a few months when you start selling off. I pulled out some of the examples from the IEEE website where they list all those product which has been recalled from the market. As you can see here, there is a product from Panasonic. This is a laptop which has been recalled. This is a power bank, which we generally might be seeing almost with everyone nowadays. I found one device which surprisingly, basically, I bought it by myself from Officeworks. This is one of the wireless earbud. And to my surprise, when I started using this device without knowing that this product has been recalled after a few months, it started heating up. And when I put into the charger, it's get really hot. And I couldn't understand why it's happening, because you can see it's just 5-volt device. It's not even, 230 volt. You are basically plugging in this device. But to my surprise, it's getting hotter when you plugged in even for 30 minutes. Then I started looking into the IEEE website and I found this product has been recalled from the market. So, and I also looked in some of those news that this product has been recalled. And as you can see from 7 News, they have put, and they said, yes, you can go to Office Work for a refund. So you can see here, if a product been sold and this has been recalled, what a big loss for the seller here. I can say this earbud was not a most expensive one. Probably it was $20, but if the responsible supplier or whoever has put this product in the market has put like nearly 5,000 of those, so they have lost $100,000 already. And it's not always a refund, it's also a loss of name in the market when you place something and people has to basically return those, so you're losing your name or faith in your brand. So this is also another important thing which people need to understand, that why compliance is so much required. Now, in addition to that, of course, for a recall, it's not a good thing. There are penalties or fines, I would say, which IEEE as well as ECMA has put into place for all those non-compliant products. What I did actually, I have pulled out some information from IEEE website as well as from ECMA website, where they have explicitly mentioned about those fines for individuals and corporate. As you can see, if you're putting a non-compliant equipment from electrical safety point, you can be fined up to $1 million, okay, which is not less. So, and then from ECMA point, people think that it's an electromagnetic noise and interference, what it can bother people, but you can see the amount of fine people are basically, or the companies or the corporates, they have to pay if they are not basically complying with those leveling notice. And they have divided into those sub clauses, which I explained, like the EMC one, then the radio communication leveling notice, if the product doesn't comply with telecom. So for example, your transmitter is basically interfering with your Telstra or any other Vodafone services, you will be fined for those things. Then there are a lot of regulations for EMR, the electromagnetic radiation, we call the electromagnetic energies. If it is above the ARPANSA level, the radiation level, you will find as well. So I put those numbers here, and they are basically from those ECMA website. Now, the biggest question is, of course, how to meet the regulatory requirement of a product. Okay. Now, the only way which we suggest is doing a testing. What I did actually, I took an example of a dummy printer. You can see nowadays the printers are not so simple. The printer has almost everything. You have a Wi-Fi, you got Bluetooth, you got 4G in that, and you want to control that printer while you're driving your car as well. So when you have all those features in a product, basically it brings all the aspect of compliance as well. So it's not a simple printer which just need to do EMC and safety in the past. Now you have to comply with all these 5 regulations. So right now I'm talking mainly on the Australian regulations, the RCM regulations, the ECMA and the EDAC one. I'm not covering the other aspect of Europe or FCC here. So what we are doing here, like if a customer comes with this kind of product to us, we suggest them to do the testing. And this is just an example for, and I have put down some of the standards basically, which is relevant to this kind of product. These are falls under the multimedia equipment they call, or sometimes they call information technology equipment, and they need to comply with the EMC regulations or the standards. The name as CISPA 32 here in Australia. Then you have the radio requirement, then you have to meet the telecom requirement because of this 4G. Then also you need to comply with the EMR, the radiation requirement, because of those radio modules which is sitting inside this printer. Plus the product need to comply with the electrical safety as well. Once you have compliance reports for all of these, what you can do, you can basically apply for this declaration of conformity. So this is the declaration of conformity from ECMA, plus you have to register your product depending on the level of product, whether it's a level 3 or level 2. And then only you can place this RCM mark. So this RCM marks basically give you the right to sell the product here in Australia. Similarly, like in Europe, it's a CE marking. Okay. Now, how we can help you, how EMC technology can help you in doing those testing. we are, as I said before, we are the most accredited lab here. You have to get the product tested in an accredited lab, because then only you can be confident that it has been tested properly. We have seen several reports coming from several labs, but we found that basically they are not an accredited lab. So it's very difficult to show a comparative results when the lab is not an accredited lab. So here in EMC technology, we provide almost all the services which is needed for a product to show compliance to any of the market in the world. So starting with EMC compliance testing, radio compliance testing, even electrical safety, environmental to do here. We do all those SAR related testing. I think we are only the one lab here in Southern Hemisphere who can do SAR testing. Then we do telecom testing, we do automotive, military, railways, and various certification testing as well. Now I know maybe some of you might be wondering, like, what would be the cost with this testing when we're talking about so many testing required for a device? You haven't planned, you know, when you started planning and designing a device for a market, we thought, oh, okay, we just design a product, start selling it. Okay, now the compliance thing's coming into play. Okay, we're happy to do the compliance, but what would be the cost when we have to do all this testing, you know? So what I try to do here, I try to break it down in a way. It's very difficult to give you a price for a particular standard or a particular product. The cost is basically varies with the complexity of the device and also the intended market. Okay, so if, for example, if you're only looking for Australia, the price will be something different. When you're looking for worldwide market, like trying to cover Europe, trying to cover America, the price will be different. Okay, but what is common in all of this is basically the cost is all based on the time spent for the testing. Now each lab has their own hourly rate or a daily rate. So what you can control is basically the time which you're spending for the testing. Now what I did actually, I tried to put a general time frame for the generic testing which is required in terms of EMC testing and radio and safety testing. So if you're coming to us with a simple product and where we are doing EMC emission testing, we generally take 1 to 4 days. So here it's very easy. Now you can calculate the price based on this, our daily rate of this product. And I have worked like in 3 major, I would say the 3 biggest companies or labs, you know, and in England as well as in Japan and here in Australia. I didn't see much difference in the pricing. Those accredited labs, their pricing are more or less similar. Of course, depending on the geographical locations, there would be some differences. But what I found, the time which we spend for testing is more or less similar in all the labs if they're doing and following the standards and following those proper test procedures and generating those test reports. Now, for EMC immunity, as you can see, we spend 1 to 2 weeks time. Then radio testing, we are spending, of course. Now, radio is something which is coming up recently. As you can see, there are a lot of IoT devices. It's not with one radio features. So it comes with Bluetooth, Wi-Fi, Zigbee, now 4G, then you have Wi-Fi with so many variations. So it all depends on how many radios we're testing. You know, if you're testing only a simple radio, it can take only a week, or if you're testing several radio, it might take few weeks time. Okay, then the same thing is again for the EMR testing. We call the electromagnetic radiation testing. We do this kind of EMR survey in a day even, but if you're coming out with several locations with several antenna towers, it might take few days even. Now for electrical safety, it's a similar thing. Like there are safety testing which we can finish within a week time, but there are certain tests, like some of the environmental testing goes like months, like 60 days of humidity testing. So the pricing would be based on those time which we spend. But what I'm trying to emphasize here is basically what you can control. Now, to summarize what we have discussed in all those, 3 discussions from Yasir as well as Scott, is basically about all this, the time. Now, the time to market, I would say, and you can control it if you plan it properly from the beginning itself. If you're utilizing a proper consultant, I would say a consultant like Scott, who is really excellent in his understanding about EMC compliance, and you're designing the product from the beginning, considering all those EMI, EMC considerations, taking care of all those EMC mitigations, taking care of all those rules which need to be put into your design so that you don't have, or you have minimal, emissions out of them, and you have solutions coming out of it at the beginning. Okay. Now that will reduce your overall cost. Now what we have found here, people come up with their devices and they try to basically do the testing, basically the full compliance, and they land up in failure, and then they go back and forth in trying to fix up and then go back to the manufacturer again, come up with a new prototype. So this back and forth is increasing their cost and delaying their basically time to market, which is basically getting, people are getting frustrated and they're really not understanding. So this webinar, we try to reach to most of our customer as well as you, to explain how important it is to take care of those compliance things from the beginning itself, and how we can basically help you to put your product into the market on time as you plan. Thank you for your time. I will basically move to the question and answer session, and probably if you have questions, let us know, or if you have already started writing your questions, we can go one by one. I'll let Les let us know, or Fatima.
Okay, thanks, Aaron, and thanks to you and Scott and Yasser for your very interesting presentations. We do have some questions already there, so we'll try and deal with them first. From Michael Fatha, he's saying, in any case, why didn't that get detected in EMC? I presume that's one of Scott's examples.
Mm-hmm.
Yeah, so I'm assuming that's the chair, or the chair standing up, or the monitor with the fluoro lights. So the reality is, Michelle, it's not the testing. Sometimes those testing in those controlled environments in the labs, they can't guarantee all situations, right? So that's why in that case that may have been certified fine, but because the certification tests aren't perfect, it's not going to actually simulate the real world. Or that's one case. I don't think that's the case. I'm being fair by putting that first. Or it's gone offshore to China, or some other offshore country. I don't know any test house in Australia who does this, but some other test house, for an economical reason, to test it, and they haven't done it correctly, or they haven't done it at all. I know I've seen myself some reports from test houses in China for not ESD, but for radiated emissions, and the graphs between two different tests were the exact same results as if they've just used the same results across different products, just to get people through past fine, and that's what everyone wants, right? Everyone wants to pass. No one's going to complain. Hush, hush. So that's another example why it's a Dell monitor. I doubt that's the case for that particular one, but nonetheless, you got to understand we're doing our best efforts here to certify these things, but it's never going to be. It works in space, in harsh environments, with someone wearing a wool jumper with a wool shirt standing out of a wool chair. It's not going to be perfect, but nonetheless, it's still an example of what EMC is. That's why I was showing it.
I will just add to Scott's point, just to explain this. I was telling that there are different requirements for the different market. So what is happening, probably this monitor might have an RCM marking on that. And now RCM marking, they doesn't ask for doing an immunity testing. So I'm not sure whether this product has gone through the immunity testing or not. So this ESD phenomena, which Scott has presented, it's basically an immunity phenomena. So what is happening if the device is not gone through those susceptibility tests or the electrostatic discharge test, it won't have been passed through that process. So in Australia and America, basically, surprisingly, they don't worry about those immunity requirements. But if you see a product for Europe, they have to comply with both the regulations, emissions, as well as the immunity. So this is something which we are trying to educate our customer as well. Like if they are trying to sell a device to worldwide, they should comply with the most, I would say, the worst case scenario. Means they have to cover both the aspect of emission and immunity. And now you can see here, there are products in the market which are basically compliance to probably an RCM marking. I believe Scott might have bought an RCM mark devices. The same thing I did as well with that wireless bud, as you can see, but it doesn't go through all those process, those extensive level of testing. It's again because of the cost, or because of the time, or because of the market. They said, okay, we are not interested in Europe. We just want to do here in Australia. So we don't care about the humidity. If there is something happening with the monitor, we don't care if there's an external influence, but they don't want to interfere. So they're just taking the emission out of it because to meet only the ECMA regulations, so I probably think maybe that may be one of the reasons, but yeah, I agree with Scott's point as well. Any other question?
Well, we have a second question from Nathaniel Marshall. Do you have any important suggested readings? I guess that's EMC references, that any general ones that you would suggest?
I will let Scott explain if he can, direct to those, EMC guidelines. But for, I would say for compliance, of course, you can visit our website. We have a lot of information in our website. Plus, there are information in Iraq website, the IEEE website, where they talk about all those regulations if you're after those information. But please do write to us if you want those information, specific to what area you're looking for. If it is something to do with manufacturing, Yashir can help. If it is related with EMC design compliance things, Scott can provide you heaps of those links. We arrange a lot of trainings here as well for those design engineers in our basic office every 2 years. And now while working with Scott, we are trying to educate our people in terms of designing as well. So yeah, write to us. We'll help you in getting those reference materials.
Okay, thanks. The next question is from Nick. He says, thanks for the presentations. What is the maximum RF frequency EMC technologies can test?
Now, depending on what you are asking, Nick, is it a radio testing or is it only an EMC testing? If it's a rated emission testing, our chambers are built to test up to 40 gigahertz basically, but we do radio testings beyond that. We got receivers, I think up to 55 or 60. I have to check exactly, but there are microwave range as well we test. I am not pretty much sure about the maximum range. I can check that one for you. You can write to us. I'll check with our radio specialist here. We deal with some of those high frequency range testing as well. But yes, most of the requirements goes up to 40 gigahertz in the EMC world.
Okay, next question from George Dryden. He again says, hi all, great presentation. He's asking a question on the IP rating. He says, we're looking at a product that is to be deployed underground for the long term. So what's the time frame for testing this type of product?
Okay, yeah, it's an easy one. Yes, we do IP testing here. IP is ingress protection for people who doesn't know IP. So we can go up to 8, I would say 6, 8 we call. No, 6 is for the dust and 8 is basically, you're going up to 30 meters or 50 meters per basically under the water. Now, exactly we need to know what IP rating you are after. It generally takes 1 day for the dust test and probably another half a day for those water ingress test. So maybe within a week time, we can finish your testing as well as reporting.
Okay, if anyone wants to ask a question, just go ahead. So
there were 2 more, Les, I've already answered them, but I thought I'd share them in case other people wanted to.
Yes, okay. Well, is anyone who wants to ask a question, please speak up now. I've got one here. If no one wants to offer another question.
Yeah, I see Mahan there asking one. So he's asking about simulation. So how do you see the role of simulation spent to reduce time spent in the lab? One of my biggest mentors and people I admire is Todd Hubing. So Todd's an EMC consultant like me, but he's also a professor, and he's done his EMC work for people like Ford and Holden Automotive, medical products. So he's a very experienced guy. He's in the US, and even he knows a lot about simulation, and he does encourage it for very minor specific cases, but generally for EMC as a concept, for far field emissions, for electric field coupling, things like that. It's really, to get anything that actually means something, it takes so much time to set up the simulations correctly that it's not practical. It's more practical to have good design principles, account for worst case emissions for all data lines, all power lines, design filters accordingly. There's a lot of, simulation just isn't, at least in this day and age, it's not feasible to try and simulate your whole product and simulate the emissions coming out of it or the conducted emissions coming out of it. So that's all I have to say about that.
There is a question from Cody, and
Yeah.
he asked, from economic standpoint, are strict regulation and certification more prohibitive for business, or do the benefits of higher quality products outweigh the initial cost? Just from our experience, because we are coming toward the end of the journey, the product development takes a couple of years or whatever number of months it takes. The product owner or the designer, they invest a lot of money to do the design, and the great products, great design is a lot of investment. And there are lots of other certification, whether it's a medical device, they need to comply with the 13485, whether it's aerospace or mining, whether it's intrinsically safe device. There are lots of investment in different aspects of getting products ready and approved to go to different market. So I would say from our standpoint, what we see, the cost of getting EMC compliance, and if you do it right, is not expensive. It is just a very fraction of the total development cost. You just need to plan ahead and get it done at the right time. And yeah, engaging the consultant is not costly. Getting the EMC technology booked for the required time, not more, not less, it is not going to cost you a lot if it's just the planning. And I won't say that this EMC, like Scott said, is not an annoyance, is not a burden, is not extra cost. It's just a fraction of your total development cost, which you need to anticipate and plan for it at the right time, and then a smooth launch to the market and success.
Yeah, I can add something onto this. Just if you're worried about the full compliance cost, we always suggest to come for a pre-compliance test. Scott always bring his products and he do like half a day check with those issues, mainly to do with emissions or immunity. And you don't need to spend that 1 week cost here, and before going to the full compliance, whether your product will pass or not, and you can do all those mitigations. So yeah, we offer that pre-compliance testing as well, which helps to reduce the cost. Sorry.
Okay, thanks.
Yeah.
We're a little bit over time, but I'll keep it going for a couple more questions. I've got one here from N, and his question is, out-of-band emission considered as an EMC issue? He says, for example, an RF plastic enclosure sealing, I guess, properly. So if so, is that a design issue?
So can you say that again? Did you say an RF plastic enclosure?
Yeah, he's asking really, I think, about out-of-band emission testing.
Spurious emissions?
Well, they could be spurious emissions, yes.
I guess spurious
do you want
emissions.
to elaborate? Are you online?
Well, spurious emissions are probably, well, as far as I know, they usually come from an intended antenna and some design flaw in the actual like radio circuitry or the radio implementation. Obviously, it's not intended. But it's definitely an EMC issue, but I personally, I've never used non-pre-certified modules. Those still need to comply with spurious emissions. But I can't really speak for, I'm not sure what the real question is. Like, is this a design issue?
Yeah, it might relate to the fact that he's talking about an RF plastic enclosure, which obviously isn't going to screen. So, a design would be to make it a proper, metal conductive enclosure.
Yep.
And
I would say in terms of like those enclosure, whether it's plastic for that shielding and like using different substance, you are not necessarily like you should not solve all the puzzle yourself. There are lots of material available. If you find a reliable, experienced manufacturer who can do this shielding properly, whether it's a plastic enclosure or metal enclosure, they should resolve this. You just need to find a reliable source and don't just go with anyone who claims that they have the experience or they have done it before. Make sure that you select a reliable source and it's not a big challenge, I would say.
Okay. We've got time, I think, if anyone has one final question. Please speak up.
Somebody.
If not, I think we're over time, so I'll close it off. And firstly, thank our presenters, Yasser, Scott and Aaron, on your behalf for their very interesting presentations, and encourage you to follow up with them if you have any more questions. So finally, I just wanted to give you an advance notice about our next Antennas and Propagation Microwave Theory and Techniques presentation. That's next Tuesday, the 27th of April, starting at 4 p.m, our usual time. The topic is antenna arrays for remote sensing and satellite communications. The presenter is Sharia Hassan Shabab, who's a final year PhD student at Monash. So thanks again to our presenters for keeping to the time and answering the questions, and thanks to all the participants, and we'll sign off now. Thank you.
Thank you, Les.
Thank you, Les. Thanks, everyone.
Thanks, Scott. Thanks, Yasser.
Okay,
Talk
cheers.
later.
Have a good day. Cheers.